Hello everybody. In this video, I'm going to be once again going through some questions and providing answers or solving them. At the same time, bring some theoretical information. Let's start. Get a periodic table with me. Okay. First question is, how many valence electrons are present in selenium? So they're asking in selenium, the number of valence electrons. So you look at the periodic table and see where selenium is. It is sixth group. So selenium is in the 6 or 16 group. So which means we take the last digit here, it has 6 electrons. Okay. So this is the information you can easily derive from a periodic table. All right, being a transition metal, rhodium can have a variety of valence electrons. So next one they say, being a transition metal, rhodium can have different valence electrons. Yes, it does. It's D, the d orbitals are there. D orbital electrons are there. Yet we can determine its outermost electrons. So we're asking what are the outermost electrons. Okay. So now this question, you understand that outermost is the last one. Okay. So rhodium is in the 5th period. It's in the 5th period. So if you take the first one as hydrogen, like that's when you go down 1, 2, 3, 4, 5, it's in the 5th. That means it should have the valence electrons are going to be from the 5th shell, because that's outside one. So what they have given here, they have given here a range of answers like 5s2, 4p7, 3f9, and 5p6. Okay, so 5th shell. So it has to be one of these things. It's by elimination. So when you go to the rhodium, it has, if you write the rhodium electronic configuration, and because it's coming from the, it passes S group and coming, and then only it comes to the D group. So for this you may have to draw the electronic configuration. The answer is 5s2. So it is better, because there's a question like that, learn to draw or write the electronic configuration. When I say draw the last orbitals, you can draw how the d orbitals are filled, 5s. So according to the Aufbau rule, it goes as 1 s2 s2p, 3 s3p 3d, 4 s4p 4d, 5s. All right. See, so all this gets filled and then comes to 5s. 5s is the outermost, so 5s2. Learn how to write the electronic configuration, where when it comes to the last orbitals, draw them like this, and use the Hund's rule to fill them, and then you remember it. So answer is 5s2. Which compound below is an ionic compound? So they're given a range of compounds. They're asking which one is an ionic compound. K2S, SiO2, 2O5, PCl3. Look at the first one where they are potassium. It is in the first group. So that is, and with sulfur more likely to make an ionic compound than any of the other ones. So ionic compound is out of the list is K2S. They have given SiF4 and asking what is the correct Lewis structure. So go back to your learning of Lewis structure. First of all, you tried the total number of electrons by getting the valence electrons from each one and add them. Then find the central atom and you put the peripheral atoms. So I put the peripheral atoms, and then with the, because there is no charge, so you don't have to add the electrons. So then you allocate those atoms. When you get the total, you allocate them to the peripheral. Okay, first you combine it, that is one. So the peripheral atoms, you provide electrons. Please check this, but I'm not going to go into detail and do another one. So when you have done that, you will see that it has fulfilled all electrons here, because fluorine is in the 7th group. So there are 4 of that. 4 times 7. That's it. Okay. So if you go to the table of silicon, is there's 4. So silicon. So 4 that is 32. So 1, 2, 3, 4, 5, 6, 7, 8. 8 gone from here. So I have 24 now. 24. So 1, 2, 3, 4, 5, 6. 6 times 4, 24 gone. So that's it. Okay. That's the silicon fluoride structure. Okay. Lewis structure. All right. So similar pattern. You have to find the correct structure for carbonate, CO3 2 minus. So when you're going to do the number of carbon is 4, carbon is 4, oxygen we have 3 times the outermost shell. You have the oxygen coming in the 6th group, so 6 coming, 18, 4, 22, but there's 2 there, so you add those 2, then 24 electrons. Okay, so do the same thing, and then you will see that carbon CO3 carbonate would have a structure like this. Could lead to resonance because this double bond doesn't have to be in this oxygen. It could move to the other one, so it could have 3 resonance structures. But from the given value, this is the structure. Okay, because this one can move here, and then like that, and then this one can move here. Then you can have. I haven't put the dots around the oxygens. Okay, and like that. So these are the possibilities. So there's equilibrium with this and this. So the resonance structure, the structure is this. So they one of them. So that they're asking the structure of SO2, and if you do the same pattern, if you follow the process given in drawing Lewis structures, you get this structure. Okay. So please do the structure and then similar ones what I'm doing here. If you keep on practicing them or remembering at least, but you need to be able to draw it from your knowledge on how to draw Lewis structures and follow those steps, and you'll get this. The next question I have here is asking which one is the most electronegative. So given a set of things like potassium, chlorine, Fe, and Si. You can see from the side when you go across the periodic table, it is electronegativity goes up. Negativity goes up, okay? And then if you go up, also it goes up, negativity. So fluorine is the highest one. So in this, what they have given out of the things, chlorine is the one answer. Most electronegative atom. Question about which bond below is the most polar. Most polar. You know, if there's a two electronegativity values, the electronegativity value is between 0.4 and 1.8, 0.4, 1.8, then it leads to polar bonds. If it is less than 0.4, then it's non-polar. If it is more than 1.8, then it is ionic. Okay? But you may not be given a periodic table with the electronegativity. So from the given values, you just compare it. So here, a bond between boron and carbon, nitrogen and carbon, boron and fluorine, oxygen, because you can see it's the same. So this is not going to be the one. The farthest apart, the two farthest apart in the periodic table, boron and fluorine. So left, and then fluorine at the right in the seventh group. So this is the most polar. Most polar would be out of the list given P and F. What you look for it, you look for the two farthest apart atoms combined. In a PCl bond, which atom is partially negative? Okay, it's easy. The one that is towards the right would be more negative. So chlorine would have partially negative, partially positive. So the answer is chlorine would be the partially negative. So if you get a question like that, that would be the answer. What we look for is out of the two atoms, which one is most towards the right. So this is a question about the shape of OF2, observed shape. Observed shape, because when you observe, you don't see the electrons. Okay, so if you take for an example OH2 like that, it has electron and it has electron here. So actually this could be not exactly tetrahedral, but it will look, when you look to the observed shape, but sorry, the shape, because these are here, this is not the observed, you get the geometric shape is tetrahedral because these non-polar are repelling these two bonded electrons. But when you look at the electron microscope, you only see that. So it's become angular or bent. Likewise, when it comes to OF2, it is also bent or V-shaped, and bond angle we can say about 109. Okay. Really, it will be a bit less because oxygen is pushing down, similar to this one, but you can say bond angle V-shaped. Okay, angle is about 109. Is more closer to the tetrahedral bond, which is 109. That's why, because 1, 2, 3, 4. So shape is tetrahedral. If you just go for the geometric shape, but it is actually observed shape is bent or V-shaped or angular. It is 109. All right, what about this one there? If you draw it, you will see the observed, because we see only the observed would be only oxygen. Trigonal plane. Observed, okay. All right. So to see the shape, you have to first do the Lie structure and then allocate the electrons correctly and then look at the shape considering the repulsion by the non-bonding electrons or the lone pairs towards the bonded pair or then bonded pair and bonded pair. Okay, look at this question about non-polar. So we know some of the ones may be polar, okay, out of the given data. This is polar, right? Chlorine. Then SiF4, yeah, it should be polar, right? This is polar. I'll come back to this one. Ni3 polar, SCl2 polar. Okay, why this is not? Is silicon and fluorine, there will be negative and positive, but because it's on all four sides, the net force is going to be zero. So the net polarity is going to be zero. So this is the only non-polar. Okay. Which molecule below uses hydrogen bonding in intermolecular force? So asking, the question is which molecule below uses hydrogen bonding in IMF, intermolecular forces. Okay, so when you talk about hydrogen bonding could happen connected to hydrogen, nitrogen, fluorine, or oxygen. Okay, so they have given like OF2, but this has to be connected to hydrogen. There's no hydrogen, that's not the one. Silicon hydrogen, there's hydrogen there, but none of those things, none of those atoms. C6H12, well, there's no carbon here, so that's not the one. N2H4, yeah, it's connected to nitrogen, so that's the one. So anytime hydrogen connected to nitrogen, fluorine, oxygen, that will form hydrogen bonds. Okay, so another question about which molecule uses dipole IMF molecular forces. NaCl, surely it's ionic. SCl2, no, it's covalent. Cl2, yes, because S, Cl, Cl, the variation is also, this will have dipole. Okay, then CO2, no, because even the separation is there, they pull each other, right? So they get cancelled out. Then I2, no, because it's the same molecule. Maximum it could have is a dispersion or the London forces. That's the maximum. So this is the dipole. Okay, you might say why it's not pulling. No, there are electrons here, so it is not 180. Okay, when it's 180, it will pull. Here, this is 180, the angle, so they pull it properly. Okay, so this is SCl2 is the answer. Okay, this is about a phase change. They're asking when dry ice, that means solid carbon dioxide, okay, dry ice, solid CO2, when it becomes a gas at room temperature, what happens? From a solid to a gas, that's called sublimation. So they are giving separate different names. They're asking melting, condensation, or freezing, or sublimation. So the answer would be sublimation. Know these terms by now when you're doing this, going through these questions. All right, so this is a case of which one will have the highest melting point. So if it is an ionic bond, it will have the highest melting nitrogen from the given lot, okay, CF4, PH3, KBr. You know, this is ionic bond. It will have the highest melting point out of the given choices. Okay. About asking how many valence electrons. So it's carbon silicon, right? It's in the 4th or the 14th group. So valence electrons, 4 electrons. Valence means outermost electrons there that can either take part in the bonding, either by removing or accepting. So if it is 4, it could give out 4 and accept 4. It's in the middle. It shares, it makes a bonding. Which compound is ionic compound? So the next question is about ionic compound. Ionic bonds. So if you understand ionic bonds, Kg, so 2, 4O10, CaCl2. You can say this is in group 2, this group 7. So that's the one that forms ionic. And I'll do the last one. If you purchase oxygen commercially, so if you get oxygen, how do they exit? They're asking. They exit like O2, that means diatomic. So other ones are nitrogen, chlorine. So these are diatomic molecules. So remember these one: oxygen, nitrogen, chlorine. They exist as a molecule with 2 atoms. They are called diatomic molecules. So remember these names, because sometimes they ask which is an diatomic molecule. Give a list. Here they're asking how would the oxygen exist as O2 or O3, which is the ozone. It is not the normal form. This is the commercial. Okay. All right, everybody. I hope this helps you to expand your knowledge or the application of what you have learned into answering questions.